Going? We're going. We're alive here. So this is section 7.1 and 7.2, okay? And this is just all about solving systems with two variables, which you've done before. I'm going to throw in a couple word problems here. Solving systems with two variables, and there's three ways you hopefully learn to solve them. One way was substitution, right? Substitution. Then you learn the elimination method. And there's another way. Anyone know what that third way is? Very good. Who said that? Very good, Nate. Graphically, okay? By graphically. And sometimes the only way to solve a system is graphically, or it would be very hard to solve in a different way than graphically. And sometimes the equation lends itself to substitution, or the system lends itself to substitution, elimination, or graphic. So we're going to do one system in each of these three ways. So say we have this system, x minus y equals 0, and 5x minus 3y equals 6. And usually with a system they put little brackets. And when you're finding a solution, you're really finding out what values for x and y make both of those equations true, and also where do those, if these are linear systems, where do those things intersect, right? That's really what you're finding when you're finding the solution to a system. And so say I want to solve this by substitution, okay? By substitution, what would I do? Solve for one variable, which would probably, well, and so what variable would I solve for? Well, I mean, I would have to transform one of these equations. What would I do with this? How could I change this equation into something where I could use substitution? Go ahead.
That's 6.
Well, no, you don't want to add 6. What are you going to tell me, Tyler?
Will you solve for y on the first one?
Yeah, you could say that y equals what? Y equals x, right? Right, if I brought the y onto the other side, right, by adding y to both sides, I have y equals x. Then I could take x and sub it in here for y, or I could take y and sub it in here for x. So that if y equals x, right, then I can plug in x over there, and then I get 5x minus 3x equals 6, 2x equals 6, x equals 3, and y equals, what's y equal to? 3, right? Because y equals x, so x and y are the same thing. You could check to make sure that's true by plugging them both in. 3 minus 3 equals 0. 5 times 3 minus 3 times 3 does equal 6 in that way. Okay? So that's how I'd solve that by substitution. How about by elimination? So same system, x minus, so we're going to solve the same thing in 3 different ways. X minus y equals 0, and 5x minus 3y equals 6. God bless you. Who could tell me how to solve that system by elimination? Go ahead, Colton.
So one value equal to the other, like multiply the top by -5.
-5 would work, or negative 3, right?
Or
Okay.
-6.
Or negative, I don't think negative 6. I think I like your -5 or the -3. Okay? But it doesn't really matter, right? Anything that's going to make the x's go away or the y's go away. So I'm going to multiply this one by -5, and people always forget to multiply. This isn't going to change this because this is 0, but if it were a number like 1 or something, right? So then I get minus 5x plus 6y equals, or plus 5y, sorry. Already making mistakes. Plus 5y, right? 5y equals 0. And then I have 5x, mind you, leave this one alone. And then I add those two together, and those go away. And you get 2y equals 6, y equals 3, x has also got to be 3, right? You've done this before, right? They get, I know this, you did this in Algebra 1 and it's easy for you, but they do get more complicated, as you'll find out in a few minutes. What if, graphically. Same thing graphically, okay? So I'm going to take the same equation, and I'm going to solve it graphically. X minus, so x minus y equals 0, and 5x minus 3y equals 6. 5x minus 3y equals 6. And you want to do this graphically. Okay. Well, you could put these into slope-intercept form, right? Or you could use the method that I kind of like, where you say when x is 0, what's y? Oh, that wouldn't work, would it? When x is 0, what's y? When y is 0, that doesn't work. So in slope-intercept form, you would have to kind of change it into a different form, and in that case, you would get the line y equals x. And if I change this into slope-intercept form, I gotta do, let's see, I get 3y equals negative 5x plus 6. And then I divide both sides by negative 3, by negative 3, by negative 3. And that turns this into y equals 5/3 x minus 2. And then I could graph those two. Ooh, that's a weird one. I could graph those two equations. The first one, we'll make it thinner. Thinner, thinner, thinner. We'll put arrows on the end. Arrows on the end. And so that first one, it says y equals x. Who knows what y equals x looks like? What's y-intercept? It goes through 0, 0, and it goes over 1 and up 1, right? So it just kind of goes like this. Oh, Connor, was I supposed to sign something for you? Oh, no. So, so it goes over 1 and up 1, so there'd be a point there. And then you could just connect those and go like that. I mean, I would use graph paper if I were doing this. Or I would use my graphing calculator. Y equals 5/3 x minus 2 as a y-intercept. See, I'm probably very inaccurate because I'm not using graph paper. A y-intercept of negative 2, and then I would go over 3 and up 5. So here's 1, 2, let's kind of try to fake it. 1, 2, 3, and up 1, 2, 3, 4, 5. So over 3 from this point, over 3 and up 1, 2, 3, 4, wait, 5. Would put me right here. Sure it would. Okay, but so if I were to make these lines cross, you can clearly see. Let's try that again. You could clearly see, how do I undo that? That these two lines would cross at 3, 3. 3, 3? They, if I graph this accurately, this would be the point 3, 3, which it kind of looks like it's about, right? 1, 2, 3, 1, 2, 3, sort of, right? So I'm just, I mean, it's hard without graph paper. But that's why it graphically isn't always that accurate. But it does work with your graphic calculator really nicely. Because sometimes in your homework, like you might see something like this. Y equals ln x. Solve this system. Y equals ln x and y equals x squared. Or something like that. And then really, there's no way really to solve those algebraically. So you would have to graph y equals ln x, which if you don't remember, it kind of looks like this, and y equals x squared, which actually looks like this. So those ones wouldn't have a solution, right? You'd end up with something different. How would you solve a system like this? I'm going to let you guys talk to each other for a minute. What if I had solved this system? Solve this system. 2/5 x minus 3/2 y equals 4, and then 1/5 x 1/5 x minus 3/4 y equals -2. And you say, I don't know how to do that, there's fractions, right? What do you think? Multiply the bottom by -2. Stephen, that makes a lot of sense. Okay? So as Stephen said, that's what I would probably do. Multiply the bottom by -2. Yeah, because then you get -2/5, and you can add them together in the fractions, with just those fractions anyway would disappear. Anyone else have another way? You might look at this. What would you do, Ella? Multiply the top. Why would you do that? Right, because then this gets rid of the fraction. Okay? So some of you guys don't like fractions, you know. So what she said, I would probably do it Stephen's way, because I'm pretty comfortable with fractions. Okay? But there's lots of different ways to do it. But I would multiply it, just so you know, because you are going to see a couple of these in your homework. But if I multiply this by 10, the reason I did that because 5 goes into 10 twice, and 2 times 2 is 4x. This is a nice way to get rid of fractions. And 2 goes into 10 5 times, and 5 times -3 is -3y. And don't forget that you have to multiply this by 10 as well, which is 40. How can I clear the fractions over here? How could I?
That'd be 15y.
Yes. I'm not warmed up yet from break. Okay. Minus 15y equals 40. Then what do I multiply this equation by to clear those fractions? What's the common denominator? 20. So if I multiply this equation by 20, 5 goes into 20 4 times, right? 4 times. Maybe I'll multiply it by -20 to make things disappear, okay? And I multiply by -20, that gives me -4x. -20 times this goes in there, -5, and -5 times -3 gives me +15. Why, uh-oh, I see something weird happen. -20 times -2 makes +40, which when I add them together, this goes away, this goes away, I get 0 equals 80. What does that mean? That means there's no solution, okay? So if you see something like that, 0 equals 80, or 5 equals 6, or 5 equals 7, or something like that, it means no solution. What does that mean graphically? Lines are parallel, okay? Parallel lines, okay? Parallel. No solution, okay? So these are both lines that are parallel. What if I got something like 6 equals 6, or 0 equals 0, or 2 equals 2? Yeah, that means same line, okay? It's the same line in disguise, okay? And there's infinite solutions, just so you know about this, okay? Which you probably learned before, but you probably forgot, okay? infinite solutions. And finally, if I get something like x equals 2, y equals 5, that means there's one solution, right? One solution. Okay. All right. Done with that? You want me to pause? Do you need a break yet? Yes. It says in, never mind. Pause. All right, pause this. No? Okay. Sometimes you have non-linear systems, okay? Am I going? I'm moving. I'm moving. Okay. So sometimes we have non-linear systems, okay? So a nonlinear system is when you have something like a circle and a line, or you have a parabola. That's not a parabola, that's a U. Or you have a parabola and a line. And as you can see, like a circle and a line could cross in two places. It could cross in just one place. It could cross in no places, right? Parabola and line, you might have two solutions. You might have one solution if it just crosses at one place. You might have no solutions if the line is down there. So you need to be aware of that when you are solving nonlinear systems. So one type of nonlinear system that you might see is like this, negative 2x plus y equals 5, and x squared plus 3x minus y equals 1. And they say solve the system. Okay? Solve. And you could solve these just like you solved the other ones, either by elimination or substitution. Probably in this case. So first of all, it'd be kind of a good idea to know what these things looked like, to know how many different solutions you have. So if I were to graph this, what shape would I get, this top one? So this is a line, right? This is a line. What shape was this over here? Anyone know what that is? That's a parabola, because if I solved it and I completed the square, which we're not going to do right now, and all that kind of stuff, I get y equals something x squared plus 3x, right? So this is going to be a parabola. So with a line and a parabola, okay, you should be aware that I could have one solution, right? If it just crosses at one point, I could have two solutions, or I could have 0 solutions if they don't cross it off, right? So you kind of have to be aware of that, okay? I think I would, how do I solve this? You can solve it by substitution. And to solve it by substitution, I'd have to get this equation. I'd have to get y by itself. So I'm going to transform this equation into y equals 2x plus 5. And then I'm going to plug that in over here, because that would probably be the easiest thing to do, right? And then I get x squared plus 3x. Don't forget, when you plug something in, you got to put it in parentheses, okay? 2x plus 5, otherwise you're going to lose your sign equals 1. And then you have to solve that, okay? So when I solve that, I get x squared. Did I do that right? I think I did it right, okay? What's 3x minus 2x? 1x. And minus 5 is just minus 5 equals 1. Keep going. How do I solve this? Yeah, you got it. Yeah, before you can factor, you can always try to factor before they get equal 0. Factoring only works if it's equal to 0 on the right-hand side. So you get x squared plus x minus 6 equals 0. And then you factor them, okay? And you set both things equals 0. And what two things multiply to negative 6 and add to positive 1? Negative positive 3 and negative 2, right? X equals positive, or X like that, right? Which means that X equals negative 3 or X equals 2. And then you have to find out what Y is. So when X equals negative 3, what's Y? Well, you plug it back into here, right? You take negative 3, you plug it back in here, you get negative 6 plus 5 gives you negative 1. And when X equals positive 2, Y equals none, okay? And just to, if you were doing that graphically, right? This one, this first equation, where did it go? Y equals, that's Y equals 2x plus 5, 2x plus 5, which is just a line that kind of goes like this, right? And this, if I were to graph it, that'd be Y equals x squared plus 3x. It's some kind of parabola, right? And so it apparently this parabola, I'm not exactly sure what it looks like. I could find out what it looks like, but it crosses at negative 3, negative 1, right? And then it crosses again at 2, 9, right? So this would be 2 comma 9, and this would be the point negative 3 comma negative 1 over there. Okay? And that's how you would solve a non-linear system. And you'll see a couple of those in a minute. So what time do we get out? 58 already? Okay. So I did have, just to show you, I was going to try to teach you these word problems, okay? Maybe I'll just go through this one. I won't do the airplane one, because this example is right in your book, so is this one, but I want to talk about just this word problem, and then I'll be done. I don't think I assigned any word problems on the homework, because at the end of the chapter, we're going to have a unit on applications, and that's when we're going to do the word problem stuff. But I would like to at least talk about it right here. So a total, where is it? Last one. Okay, and this is kind of a classic problem that they like to give you again and again. A total of $12,000 is invested in 2 funds paying 9% and 11% simple interest. The yearly interest is $11.80. How much is invested at each rate? So, so that's your question. And usually what you want to do with a word problem is set up your variables, okay? And since this is in the system of equations section, you would probably want to let x equal something and let y equal something. So what do you think I should let x be? Amount invested at 9%, okay? Amount invested at 9%, and then y is the amount invested at 11%, right? And then I want to write a system of equations. Who could give me one system, one equation?
X plus Y equals 12,000.
Very good. X plus y equals 12,000. Who can give me the other equation? Go ahead, Nate.
Is the other one like 0.09x
Yep. 0.09x, yep.
plus 0 or
0.11y equals
1,180.
1,000, exactly. Very good, okay? 1,180, and this is a system, okay? Now, I know some of you don't like decimals either, but you could solve this either by substitution or by elimination. I think the easiest way is by elimination, maybe. Let's see. What could I multiply this equation by to get rid of those decimals? 100, right? Because that's going to turn, if I multiply this by 100, that's going to turn that into 9x, isn't it? 9x, wait, 111y, right? And at the same time, I'm going to multiply this one. Since this is going to be 9x and 11y, I'm going to multiply this by negative 9 up here. Because I want to get rid of that 9x. See what I'm doing? Now, you don't have to do it like this. I think in the book they do this one by substitution. They solve for x and they plug it in here. But I don't like decimals as much as the next guy. So now I'm going to change this into negative 9x plus minus 9y. Okay? I'm losing you already. Okay? Minus 9y equals, what's 9 times 12? Something that indicates. What? 108. Negative 108,000. Okay? And then when I multiply this through, what's nice about that, that turns into a plane 9x. This turns into a plane 11y. And this, I just move that comma over one place, right? Two places. 110,000, no. Sorry. 111,800, right? Is that right? One more zero, okay? And then I add them together. When I add them together, that goes away. I get 2y equals 10,000. Oh, easy. 10,000. So y equals 5,000. Numbers work out nice. And x equals 7,000, right? Just plugging back into that first equation. But this is a problem that you'll see over and over. It reminds me of I told you guys that I once dated a banker, right? Yeah, I dumped her though because I lost interest. Okay. I didn't make that one up. I stole it from the Pretty Good Joke book. Okay. That's the end. Whoa. I only talked for 27 minutes.